Richard. And again, hopefully everybody's here for the right session. So we're streamlining security API management with Kong and Traceable. So really happy to be here to chat with everybody and get about a little bit of your time. As mentioned, I'm Dan Temkin, Technical Product Marketing Manager for API Security for Kong. And Sudhir?
And I'm Sudhir Padamsetti, Senior Director of Product Management at Traceable by Harness.
So we're going to kind of go at a rapid pace today, looking at, talking about the API explosion, coming back to fundamentals and the foundations of APIs, a little bit on the security challenges, ecosystem strategy of how Kong and Traceable are working better together, and then, of course, give you some time for some Q&A. So hopefully we can keep this fun. So as hopefully all of you are aware, and you've been seeing slides similar to this throughout the whole of our sessions, the explosion of the number of APIs and the different types of APIs has grown dramatically over the years. But at the same time, as we've been exposing these different APIs, and let's break it down. The APIs are just the contract, just the interface that we're consuming. It's our business and data services is what the APIs are providing. That's a core asset of our business, something that we need to be worried about. How is it being used? Who's using it? How can we better protect it? Because that's a big part of our business. The API is just the access point, whether it be a REST API, an event endpoint through Kafka, a new LLM-based AI, or through an MCP server. But that explosion of APIs, we have thousands of endpoints. Most organizations I talk to, when I say, how many APIs do you have, they might go, I actually don't know. The APIs that they might be managing might be in the hundreds to thousands. But the actual total number of APIs, accesses into the different business and data services of those organizations is exponentially growing. So that introduces a lot of security challenges for organizations, but also a lot of opportunities that we can talk about. Oh, jumped too many slides. And APIs are everywhere in our organization. Every project that we talk to companies about are leveraging APIs. And again, I'm using APIs in that general sense, whether it be a Kafka event, an MQTT endpoint, a REST API, a traditional SOAP service that's maybe exposing some legacy Java code that's been running for the last 20 years. All of these different services are important and critical, and we need to be thinking about how are we securing and managing them. Now, there's all the fun stuff, those innovation APIs that we like to talk about and think about, the ones that are being exposed to the public and going, okay, that's where we can focus. But at the same time, there are those back-end core legacy APIs that we developed 10, 15 years ago that are probably still running somewhere inside your organization. And all across that spectrum of use cases that we need to be thinking about, how can we better protect our organizations, protect our data and business assets in allowing us to consume them and expose them in a reliable fashion. So when we look at the criticality of APIs, most organizations, and this is from Akamai, another vendor in the space, has said that 84% of businesses have had some API security event in the last year. Now, as we can imagine, because we don't see API security events every single day in the Wall Street Journal, most of those API security events go quietly. And they happen inside the organization, and we try to patch them and take care of them because we don't want those API security events that make it to the front page of the journal. We don't want those that impact our stock prices or our valuations or our customers' perception of our organizations. So we need to think about how can we make sure that we're best securing our, again, digital business assets in this landscape. And when we look at some of those other facets, 81% of organizations say that an hour of downtime costs over $300,000. And a lot of people go, wait a minute, Dan, you're flipping. You're going from security to system reliability. Well, a lot of times what's causing a system reliability issue is someone that's poking away at that API. They're providing a threat vector against the API or the backend business service that might actually take down that system because we're not properly providing protection. Now, at the same time, those are kind of those traditional classic APIs. Gartner and others, including us, are saying that the radical growth in API security breaches is going to continue to increase. As we also extend the number of APIs, the more endpoints that we have, the more entry points, the leaks, if we want to think about the areas that we have to patch and fix, keep increasing. And API management is a big part of that story. How can we look at taking those APIs that we're dealing with and providing both static, where we, in design time, understand how we can protect those APIs, as well as dynamic threat detection against those. So often in organizations, so actually let's do a quick raise of hands. How many of you are buzz over here? APIs are everywhere, and think about that with excitement. So you're usually the API evangelist, the API developer. How many of you are those folks in the room? Only a few. Okay, a few. Okay, I'd expect more of those. How many of you are the Woody character here of APIs are everywhere? This is a security risk. This is a concern. This is keeping me up at night. How many of you are that in the room? Okay, a bunch of you didn't raise your hand. I'm curious to talk with you afterwards and figure out where are you on that spectrum. And really, we find that there are both personas inside of organizations. I have the app dev teams usually. It's APIs are everywhere. I can solve the world's problems. I can build on innovation. And then there's the security team that's often coming in after the fact, after the APIs have already been deployed, going, oh, you have an API for that, and that's exposed publicly? Oh, okay, let's talk. Let's get concerned. So some of those concerns, and I'm not going to go through this whole chart, but yeah, it's the first of how many APIs do I have? You know, there are the managed APIs, but there are plenty of APIs, and we have lots of different names for them: shadow APIs, zombie APIs. Where are all of those APIs? What are they doing? What are the known vulnerabilities in my environment? And also, even more scary, what are the unknown vulnerabilities in my environment? Where are misconfigurations, especially drift over time? Oh, we had a problem with a certain trading partner that was using our APIs or a certain mobile client, so we implemented a little fix in production. Well, did we ever go back and do a security test to make sure that that little fix didn't open something up? So that configuration drift, what's going on? And of course, then there's, where are these APIs? Are they all inside my data center? Do I have them spread across multiple hyperscalers? Or is there's a gray box sitting somewhere that's hosting a HTTP endpoint that I don't know about? Again, all of these things can bring up concerns. And then, of course, lastly, what are these endpoints actually doing? What data is flowing through them? What possible information that I might know about as part of the contract, where I thought that's what the API was providing? And what information is actually going through that API that might be being passed as either the configuration's changed or the undocumented features getting leveraged. So it's really an area that we have to be thinking about. And of course, a lot of us in the security space, this keeps us up at night. So one of the areas we need to first start with is a good foundation. And I often like to think about that as, we're building a house. And I need a good foundation. If I just have a plot of land, and I get, oh, I'm not worried about the foundation. I'm going to throw up some beautiful, some walls, a roof. I'm going to focus on building that kitchen of my dreams. But I never really worried about the foundation of the house. That first big rainstorm, that first earthquake comes, and my house falls apart. So sometimes there's the not fun stuff that you need to do about just let's start with a good quality APIs and kind of going through our catalog of services and going, how can we improve them? And some that's just going back to the fundamentals of why is this API even out there? Who's using the API that I have out there? Is it well designed? Is it leveraging the right protocol and communication path? Is the schema well documented, or is it just kind of that HTTP endpoint that's passing out strings? And maybe it looks like JSON, but is it really, has it been well documented for usage? And of course, from a security standpoint, we're here looking at from a secure and protected point of view of, is the security that was defined on those interfaces, is it well defined to meet the needs of the business, to meet, let's say, a regulatory compliance? And is the security that was defined actually being implemented? And then as it's being used, is there different vectors of attack that's being leveraged against that API that we need to now go back and change that service to go back and protect itself from? And of course, we can look at performance and observability and reliability as additional facets. And we could spend a full day going in depth in each one of these, what makes a good API and how can we deliver those good APIs to our organizations. But we're going to keep focusing on security here. So from a Kong unified platform perspective, and I assume everybody here is in some way leveraging Kong or looking at Kong as part of their enterprise solution, we're here to make sure that we can provide a unified way of delivering all forms of APIs. Whether it be REST, SOAP, gRPC, whether it be our AI interfaces, whether it be our MCP interfaces, eventing now, leveraging microservices with Kong Mesh, again, providing all of those different interface standpoints, access to your core business assets. and do it in a way that provides reliable declarative security, reliable declarative interaction with those systems, and provide a universal observability layer so I can see what's going on in my systems. And do that in a declarative approach. So I don't have to have a developer team going, oh, you're writing in this Java framework. Go figure out how to do OAuth in your framework. Oh, you're writing in Node.js. You need to pull in these NPM modules. Oh, you're writing in this outdated Python Flask. Oh, I guess we won't have security with you because you can't support it right now. So by providing a unified way of delivering security above those application layers of all those different logics, we can create a consistent approach. But the consistency that we can provide is only based on the known security patterns that we had during design and development time. So that still leaves an area of a gap. So even with having a Kong as unified platform, I can still look at how can I identify security risk points in my API that might not be easily identifiable just by having, going through the standard review processes and quality checks. So how can I look at fixing those in pre-deployment? How can I have automated testing to do that? How can I identify security risks of my running applications by looking at the actual way they're being used versus the way they were designed to be used? Again, there's that disparity between those things. How can I detect malicious activity? And to me, malicious activity doesn't just have to be that external user that's trying to do poke a hole in the system. It could actually be an internal user that just wrote bad code, and it happens to create that same behavior of malicious activity. I was in a great hackathon a few years back, and we had someone that was doing a mobile application, and they happened to miswrite their code that every time they moved their finger on the screen, it was actually making multiple API calls, even though they really only want to be an on-click event. And so they just wrote the wrong event code, but that created a denial of service attack against the backend API. So again, malicious activity can be in multiple different forms, and we have to kind of get creative and think about where is malicious really mean and which ones do we want to protect ourselves from, and how can we protect ourselves from that? And can you block the targeted API, the attacks against those APIs? How can we do that in a very fast and reactive fashion? So from a Kong's perspective, we're really good at that kind of shift left security through declarative approach. But how can we leverage that shield right? So here's where I'm going to hand it off to Sudhir from Traceable.
Awesome. Thanks, Dan. So what is Traceable? Traceable is a leading API and application security platform that secures your apps and APIs across the entire lifecycle. It combines API discovery, real-time detection, API testing, and runtime protection in one solution. So there are three main modules or pillars of Traceable. The first module is discovery and posture management. So we continuously discover your APIs, no matter where they live, including third-party APIs, shadow APIs, and so on. And then we map the sensitive data that's flowing through those APIs, assign risk scores to those APIs, and help create governance policies for those APIs. The second pillar is API testing, where we are able to do context-aware testing throughout the lifecycle of APIs. And we also have DAST and API-specific tests. We fit natively in the CI/CD pipelines. We have native integrations with several CI/CD pipelines. And we harness being a CI/CD player. We help identify and fix vulnerabilities early in the SDLC. And then the final pillar is runtime protection, where we combine WAF or Web Application Firewall, API security, bot protection in one platform to help you secure your APIs and apps against OWASP top 10 threats and beyond that. So now the combination of Kong and Traceable is like a unified API management and security platform across all your environments. With Kong, it standardizes how APIs are built and how they are run and how they are governed and how they are actually stored in catalogs or developer portals or provide consistent governance. Traceable, on the other hand, complements Kong by, number one, is doing continuous discovery of your APIs in every environment, helping identify vulnerabilities early and helping you fix those vulnerabilities early. And once your APIs are in production, doing that continuous behavioral analysis to identify and secure your APIs against a wide range of business logic threats. So the combination of Kong and Traceable is like a unified API lifecycle management solution, which gives full governance, control, and visibility, helping you secure your applications and APIs at scale. So in this diagram, we see that Kong does a great job of helping API consumers send secure requests. We do this at Kong basically by routing all the requests for all the services through Kong, creating that controlled entry point, which makes it super easy to enforce security policies. And then Kong Connect takes it to the next level, where it simplifies management and configuration of multiple gateways across different projects and teams. Now let's bring Traceable into the picture. So how Traceable? So Traceable is a web application and API protection solution, which integrates seamlessly with Kong. The integration happens primarily at the Kong gateway level through the Traceable plugin. So now Traceable complements Kong's security posture. So by doing this continuous discovery of APIs, identifying a lot of business logic specific threats. So for example, let's say we are continuously monitoring the traffic that's coming from different API producers and also consumers, and looking at the full API calls and sessions for a period of time. For example, we establish a baseline behavior of your APIs, and then we look for anomalies on top of that. So for example, if there is like a 5 KB is a regular payload size, but then we're seeing a lot of anomalies in the payload sizes or content types. So we identify all those anomalies in real time, and then identify all these different threats and help you mitigate those threats with dynamic protections. So the combination of Kong and Traceable here is like an adaptive security solution that helps secure APIs and applications in these dynamic moving environments. There are additional integrations of Traceable with Kong. The first integration point is, of course, the gateway, where we have the plugin. The other integration point is through the Kong's service catalog. So all the APIs that are discovered through Traceable can be inventoried and then actually sent to the Kong service catalog. So it basically helps you identify and govern all these unmanaged APIs and then bring them under compliance using the Kong gateway. Then we also have a deployment option called eBPF agent, which can be deployed at the host level, which discovers all your APIs at the host level. So all the APIs that we discover, either through the integration with Kong gateway or with the eBPF agent, all these APIs are inventoried back into the service catalog, helping you do that good API visibility, governance, and compliance. So now Traceable is completing that full picture for you, like no matter where your APIs live across all your environments, whether they are going through Kong or not going through Kong, we are able to discover all those third-party APIs, shadow APIs, unmanaged APIs, and help you create that up-to-date inventory of your APIs from a compliance and governance standpoint, and also secure those APIs real-time in production, at the same time being able to test those APIs early in the SDLC process. So to summarize, like every organization wants their APIs to be in the top right quadrant. That is like the known and managed state. But very few organizations are currently there or get there eventually. Managed is more like a subjective word. It means your API is well documented, it's secure, compliant, and you're continuously kind of learning about that API on a regular basis. So on the bottom left side, you have these unmanaged and unknown APIs, which are also known as zombie APIs. These APIs exist in production and are being used, but no one has any idea about those APIs. They're not maintained or monitored, and these APIs pose a lot of business risk to the organization. And then in the bottom right quadrant, you see the unknown and managed APIs, which are known to some extent. Some teams in the organizations know about them, but not everyone has full awareness of those APIs. So these APIs still pose that risk. They're known as rogue APIs. They pose risk because they're not going through that real API governance program where you're not continuously monitoring and getting visibility on those APIs. And then at the top left, you have these unmanaged and known APIs, which are actually going through that transition phase of being identified, prioritized, governed, and being secure. So eventually, the goal is to move all the APIs from these 3 quadrants through the top right quadrant, which is the known and managed segment. That is when you have a real good API lifecycle management and an API governance program, where you have an up-to-date inventory of all your APIs, and you're able to prioritize, secure, make sure they're compliant, and govern those APIs. So this is where the end state is, and this is a continuous feedback loop process that happens, and then an organization eventually reaches this ideal state. So this is where Traceable and the combination of Kong helps organizations get that unified API lifecycle management, and at the same time being able to secure those APIs in production.
Again, so thank you everyone for taking the time, staying back this afternoon for that awesome presentation. Maybe just a quick round of applause for the gents. Thank you.